Let's work a problem for projectile motion that are launched horizontally using this Phet simulation. This Phet simulation is a great way to work problems and to check your work immediately. It's also a great way to get a multiple numbers of problems in a short period of time, and you'll always know if you're right or wrong. So the first thing we want to do, if it's launched horizontally, our cannon or our launcher is at 0 degrees, so that's horizontal, and let's give it a height of 9 meters. Let's give it an initial speed, let's do 14 meters per second. The first thing that I want to do is I want to measure my height. Well, that's 9 meters, so my height is 9 meters. With this formula, I can calculate how much time it takes for the object to reach the ground. Let's get this one. 9 is equal to 1/2, 9.8 t squared. So it's going to be 9 divided by 4.9, which is half of 9.8 t squared. So that's going to be 1.83, or 4, is equal to t squared. Let's go do the square root of those. So my time is 1.36 seconds. So I know that the time that the projectile is in the air, remember when we do projectiles, it's always flight time, it's air time that we consider. So the time that the object is in the air is 1.36 seconds. So I'm going to clear this. So I'm going to put that up here. My time is 1.36 seconds. So my horizontal, so now I've got the vertical, so now my horizontal, my Vx is equal to dx divided by time. So dx is equal to Vx times time. So my dx is going to be equal to, my Vx is 14, it's right down here. My Vx is 14 times my time, 1.36, because remember the horizontal component remains constant. So my horizontal distance is 19.04 meters. So what I want to do is I want to put this target at 19.04 meters, or as close as I can with this simulation. So let's move this 19, let's put it at 19.1, and let's see if we actually can hit the target. And there we go. We have hit the target. We were successful in our calculation. Let's do one more. So let me clear this. So let's move this up to 13 meters, and let's give it a speed of, let's see, if I get it too fast, let's go to 17 meters per second. So now I have a y distance of 13 meters, and I have an x velocity of 17 meters per second. So once again, first thing I'm going to do is I'm going to find time. So 13 is equal to 1/2, 9.8 t squared. So my time, after I do my calculations, is 1.68 seconds. So now I'm going to take that time, my Vx is equal to dx over t. So that's going to be, my Vx is 17 is equal to dx over 1.68. So my dx is equal to 28.56 meters. Let's put the target at 28.56 meters. That's going to be close. And let's fire. And once again, we've hit the target. We were off a little bit just simply because of our decimal places. So this is a projectile launched horizontally. Readjust your parameters, change your height some, change your speed, and see if you can't get 3 or 4 in a row.